Hi again, I'm Brett Manning and I lead tokenomics here at the Giant Protocol. Today we're going to do a deeper dive into how the core DCT contract works in the Giant Protocol. You may remember from the white paper or from previous videos that DCTs are tokenized versions of prepaid data plans. So for example, 5 gigabytes of data available in the US for 30 days would be a good definition of a DCT that you could buy on our chain. These DCTs are backed by a pool of Giant tokens funded by the community to ensure quality of service. When a DCT expires, or if it's fully consumed, a share of the DCT sales revenue goes to those stakeholders as a reward for guaranteeing the service. In the event that there's a refund, so that is, if there's a network outage or something happens where the provider is unable to provide the data that was promised, the refund is paid out of the pool and the provider accrues a debt to that pool. That debt has to be repaid from future DCT sales. And so what we get is a flow of tokens through the system that rewards the stakeholders and the providers and pays protocol fees. So what I'm going to talk about today is a deeper dive into how we allocate the sale of a DCT. So when someone buys a DCT on our chain, some of the value is put into escrow and held against potential refunds. Some of it is put to one side for protocol fees. Some of it goes to pool yield, and the remainder is given immediately to the provider. What that means is the provider can get the funds quicker. They can sell data up front before the service is delivered, but the consumer still gets a guarantee that they're going to get the service or a refund. So what determines how much the provider gets in that initial tranche? Well, it's going to be a function of a few different variables. And what I'm going to do is talk you through some of those right now. To do that, I'm going to use this Jupyter notebook, which I'll make available attached to this video. But in short, we're going to start out with a definition of the protocol fee and the pool yield. In the white paper, we have a 5% protocol fee and a 5% pool yield fee. Let's find those. And then we define the amount of collateral that we're going to hold aside against potential refunds. And we have two parts to this. One is determined by the provider pool and one is determined by the debt owed to that pool. So if we look at this first one, we have the collateral PP, which is a function of this ratio. So debt plus TVO. Debt is how much debt the provider owes the pool. TVO is the total value of outstanding DCTs. So that is all of the sales of DCTs less any expired ones. And SPP is the size of the provider pool. Now I have an A value, an A function here, an accelerator function that I'll come to in a second. But I want to talk about the other collateral, the debt collateral, which is the ratio of debt to the price of the DCT. So this is how much of the DCT I would need to take in order to repay the debt. Obviously, this can't be greater than 1. I can't take more than the entire sale. But the idea is I want to, if the provider owes $5 and the DCT is worth 10, then 50% of the sale would pay off the debt. But this accelerator function kicks in before that. And the accelerator function guarantees that rather than putting 50% aside just to pay off the debt, because there's been that refund in the past, we're going to take slightly more as a precaution to make the protocol safer against future refunds. So what I'm going to do is I'm going to define this collateral, which includes this A function, and then we have the accelerator function itself. Now, the accelerator function has this S parameter, which we set to be 1. Again, this is in the white paper. And the accelerator parameter itself is this quasi-sinusoid, this exponential decay function that looks like this. So let's have a quick look at what that is. So as I said, if the refund was 50%, then rather than just setting aside 50% in escrow, which would be the blue line, we'd set aside slightly more, 63 or something, on this red line. And so this is a way of penalizing refunds more stringently. We also apply this to that pool ratio, the TV over SPP. And so what that means is that the size of the pool has to be very large before we hand over all of the revenue immediately. So what I want to do is have a quick look at how that works. So I've created this immediate revenue function. And so the revenue that the provider gets will be as a fraction, 1 minus the protocol fee, minus the pool yield fee, minus any collateral that is set aside based on the relative size of the debt, the TVO, the SPP, and the price of the DCT being sold. Obviously, you can't get, we never take money from the provider. We only take money from the sale of the DCT. And so this can't be greater than, we can't take more than the entire sale. So this is floored at 0. So then if we do a quick example, let's set our DCT price to be $20. And let's say we have a pool of $1,000 or 1,000 giant, a TVO of 80 giant. Let's assume there's no debt, and let's have a look at what the immediate revenue is. So in this case, we have $15. So out of that $20 DCT sale, 15.57 of the value goes to the provider immediately, which means the remainder, $1, 5%, is held for the pool yield, $1, 5% is held for the protocol fee, and the rest is held in escrow as a protection against future refunds. Now what we could do is we could have a look at how this looks when we combine these things. So what I'm going to do is I'm going to plot immediate revenue as a function of the pool size. So this is assuming our TVO is still $80, assuming that the price is still $20. If I have a very small pool, so if my pool size is say less than 80, then there is no immediate revenue. All of the revenue is held in escrow until the contract is fulfilled. Whereas what you can see is there's a very steep curve here that as the pool size increases, more and more immediate revenue is passed across to the provider. This is only one dimension, obviously. There are lots of dimensions in here. And so for today, I'm going to focus on SPP and TVO. And so I'm now going to just do a quick 3D plot. Again, you can play with this yourself. But what you can see is that for these states down here, where I have pool size on the x-axis, I have outstanding DCTs, my TVO value on the y-axis, and then the immediate revenue on the z-axis up here. And so when the pool size is small compared to the outstanding DCTs, we get no immediate revenue. But as soon as the pool size is relatively large compared to the DCTs, it very quickly means that the provider can get much more of that revenue much sooner, while still guaranteeing that the customer can get a refund. So this is really providing liquidity support to those providers. And this is potentially really important because it means that the provider is insured against any kind of catastrophic outages. It also means that consumers can trust providers who maybe they wouldn't otherwise, because we have this community backing in the pool. This is the kind of analysis that we do to build up our tokenomics here, and it's very similar to the underlying model or the underlying code that's actually behind our simulator. So since the last time I did a video, I've added a provider data button. In the base simulation, we have 10 different providers that we simulate randomly these events. And so sometimes there's a debt, sometimes there's no debt, sometimes the pool is very large, sometimes the pool is not very large. And what you can do is you can download the provider data. It's a pretty big file. So it'll take a second to download. And what you'll see in this file is TVO, size of the pool, and how much is held in escrow. So if I open my Excel. So here we have TVO, pool size, and the revenue and delayed revenue. So delayed revenue is that escrow, what is withheld. So what you'll see is that when the pool size is small, there's more delayed revenue. If we find like where pool size is bigger, you can filter by there. So pool size. Smallest. When the pool size is large, you can sometimes get 0 delayed revenue. So this is where, what's the difference between the areas where pool size is large and delayed revenue is large? Well, TVO is the answer. So again, This is a tool that you can play with. I will put a link to it in the description of this video. You can take a look. In my next video, I'm going to talk about what happens when there's a refund, how we calculate debt, and which payments go to where. But for today, that is how we calculate immediate revenue. Any questions, drop me a line, Discord, Telegram, or Twitter. Thank you very much. Bye.